Hello, Java programmers. Let's talk about methods. Methods are a crucial building block of all the code that we write. One thing that we've noticed over time, we learned it the hard way, is that it's very difficult for us as human beings to deal with large volumes of code at a very low level. A program could be thousands or millions of lines long. I mean, if you run Microsoft Word, there's probably millions of lines of code all put together to let you manipulate Word documents. But nobody who ever lived or who will ever live understands all of it. We divide it up into parts and we assign those parts to different developers, different engineers, testers. And one way we divide it up at the development level is through methods. And we'll create a method that does one thing, one understandable thing, does it correctly and well, and then we'll use that as a component of a larger product. So methods are essential to your understanding of programming, and this applies to any language that you're going to use to develop anything of scope. If you're writing a little 10-line program, then you can certainly put everything in the main and be on your way. We also want our code to be reusable, meaning that if I write code, I would like it to be pluggable, so to speak, into other projects to make me more efficient, to make me more valuable to the company, and it also increases job satisfaction because I'm not writing the same code twice. And one of the ways we do that is through methods. Looking ahead, we're also going to implement classes that are the true foundation of portability. And we'll see more of that next semester in Java 2. We write modular code, that is code broken up into modules or methods. Now, I have used the term module to refer to a file, and that's kind of a specific term. So when I have said module in the past few weeks, I've been referring to a file, main.java, classes.java, password.java, whatever code we've written. But in the general sense, modular code means code that is broken up into pieces and can be reused across projects. These are the things we want our code to be able to be. Modular code is understandable more so than huge thousands and thousands of lines of code because it's broken down into little parts and it's easier for our minds to get around it. It's maintainable because if we make one change to a method, ideally we only have to test that method. We don't have to test 10,000 other methods. Of course, we're retesting the system again, but the testability quotient, the capability of testing is reduced, or the need for testing, I guess, is reduced because we wrote a little change to a little method and we didn't make wholesale changes to large thousands and thousands of lines of code. Reusable, of course, we can write a method, put it in a class, and then give that class to other developers. And again, reusability is primarily a concern of creating reusable classes, but we still think of reusability in terms of methods because we can call that method multiple times from within the same program. So instead of repeating that code over and over, we simply invoke the method and we're reusing that code from that standpoint. Our terminology, a method is a named hunk of code. I'm using the term hunk till I get something more specific to talk about, which we will. And if we want to be even more specific, this named hunk of code is in a class. At this point, we don't know anything about classes. Well, we know we've been using them like crazy, but we haven't discussed them in any detail. So we will suffice it to say at this point that a method is a named hunk of code in a class. Now, if you dig a little deeper, there is another term, function. And a function is a named hunk of code not in a class. A lot of us use the terms interchangeably. I know I do. So it's okay if you fall back into the habit of referring to that hunk of code as a function. We get your meaning. We know we're in Java. And in Java, there are no bits of code that aren't in classes. Everything has to be in a class. Therefore, every instance of a named hunk of code, I'm using that term hunk a lot, is a method. So strictly speaking, there are no functions in Java. Other terms that you may hear people use are procedure and subroutine. Again, those have strict definitions as well, and they can be argued. Computer scientists who study compilers and software engineering may quibble over the strict definitions of these terms, but we will use them interchangeably in this class. Method, function, subroutine, and procedure. You're going to primarily hear me say method, and sometimes I will drift back into saying function again. We already use methods. Everything we've written to this point is in the main method. We've also called methods. We call println numerous times to get output. We call nextInt, part of the scanner class, to get input from the keyboard. And we already know that the parentheses indicate the invocation or the call of that method. Now we're going to talk about the nuts and bolts of writing methods in our own code. We'll continue to use methods such as these, println and nextInt, because they're good, working, proven methods. There's no reason to rewrite them or replace them. They work for us. They work for everybody else. We'll leave them alone. Now, I've been saying hunk for the past couple slides, but strictly a more formal definition is a block. Anywhere you see code delimited by curly braces, that's called a block. Therefore, we can revise our definition of a method and say it is a named block of code. We've seen blocks already in for loops, in if-else statements, in switches, and also the main method is a block of code called main. The main class, sometimes we call it something else, but whatever class we've created in our project is also delimited by braces, and that's also considered a block. Your job to this point has been to make those braces match up and to format the braces properly, indenting, outdenting, so it looks nice when you're finished. We're also changing the way we think about work. In the real world, in a production environment, you're going to be given a job to do as a developer, and that job may be described by write a class that does something. And this is the situation where you're starting from scratch. You don't have a project that you are working from, or you have a project and it needs a completely new functionality added to it. And your way of thinking about that problem is writing a class. In that class, you will have methods. When you think about writing those methods, here's the mindset that you have. Write a method, for example, that calculates the cube of a number. You don't think about that from the perspective of writing a program anymore. Because I don't want, if I'm working with you, a program that calculates the cube of a number. I want a method inside of a class that calculates the cube of a number, and then I will put that into my project, into my program. But you still need a program in order to demonstrate that your code works and to test it. But the mindset is eventually the class that you write that contains the method that computes the cube will become part of other projects, and those projects will have their own mains already. And we talk more about this in greater detail in Java 2. The first line of a method can be called the method signature. What we're primarily concerned about in this class is the return type, the method name, and the parameter list. The public and the static we're going to ignore for now. So we will make all our methods public static. But we're going to be looking at different techniques for changing the return type of the method and the name of it, and of course the parameter list. Here's a blow-by-blow breakdown. This method is called cube. That's the named hunk of code, the named block. The method returns an int or integer. We've seen integers already. The method expects you to send it one piece of information, which must also be an integer, and inside the method it will be referred to as number. And you need to be able to look at this and tell me exactly what all these parts mean. The public means that it's visible outside of the class that it's defined in. The static means that you do not have to declare an object to use this method, and you don't have to know any more than that for the public and static, but the int, the cube, and the parameter list you must have down cold. You must be able to explain it, create it, manipulate it, understand it. Once we have the method signature, we could compose a flowchart for that method. Flowcharts are still used, believe it or not. They have a great way of communicating logic without all the burden of creating an Eclipse project and a class and a package and all that other stuff. You don't even need Eclipse to do this. You can do this as part of the design process. Don't get the impression that this is old news and nobody does this anymore. This still has great value. This is an implementation of the cube method that we've been discussing on the past few slides. The first rectangle is the signature, except for the public and static. We generally don't put those into the flowchart. The second rectangle declares a variable. And notice the syntax in that second rectangle. There's no semicolon. There's no indenting. This is pseudocode. This is metacode. It just tells you how your program should be written, and then you have to translate this into Java. Now, I've given you a lot of pseudocode, but it's been textual. It hasn't been symbolic in any way, so this is a new thing for us. The third rectangle defines the computation that's taking place in that method. Then the fourth symbol is that flattened oval. That means the function or the method is done. See, I called it a function again. The method is done and it is returning the value of result to the calling method. Every method is called by some other method or it has no value. So we're writing this wonderful method called cube, and until we call it, also referred to as invoking it, then it has no value, it never runs. So before we move into this practice exercise, let's implement the cube method that we've spent the last few minutes discussing. And I have Eclipse open. How about that? Nothing new yet. I just went ahead and created the project for us. I called the project Methods. I created a class called Methods because it seemed like a good idea at the time. We don't have a lot of context here, and I just did the best I could with the class name. The package is also called Methods with the lowercase m. And what we have done up to this point, before we knew anything about methods, is we would just say int num equals 42, print num times num times num. Print the cube of num. Okay. And I got lazy on the print, but to make the errors go away, let me just be more precise about that. System.out.println. There we go. That's what we've done up to now. If I had asked you to do this last week, I would say write a program that calculates the cube of a number. And that's what you would do. You turn that in and you document it properly, everything would be great. But that's not what we're doing anymore. We are going to implement this in the form of a method, and if you back up to slide 9, you can just copy that method signature verbatim. That's the first line of the method. It's been written for you. Sometimes they will be written for you. Sometimes you will leave a meeting with the other developers and you will negotiate the method signature. Everybody else will know what you're going to do and how to talk to your method. That no one else will care how you do it because they don't want to look inside your method. That's your job. But they want to be able to use your method, therefore they need to know the signature. Sometimes you'll get that signature in that meeting. Sometimes it will be transmitted to you by another developer. Sometimes you'll receive it in a design document from a systems analyst. Sometimes you'll just get to make it up because you realize that it's necessary for your work. Nobody told you to do it. You just know you need it. But we have it. Let's use it. Now here's the first trick. The first trick is that where does it go? It goes under the main, outside of the main completely, but inside the class. I pasted in that line right off the slide. It's very unhappy now. Eclipse is having a fit because I haven't finished my thought. The syntax is still incomplete. The first thing we can do is immediately put the block in. All right, if you add the opening curly brace, Eclipse will automatically pop in the closing curly brace. I like to have the opening brace on the same line as the signature. That's just my preference. Some people put it down on the same column as the first character in the signature. I'm just not fond of that. I don't care how you do it. And then the code goes inside that method. Now we have a problem immediately because the method is committed to return an integer, hence the word int in the signature. We're not doing that, and Eclipse is telling us we're not doing that. And that's fine because we haven't got to it yet. That's an error that we know we're going to fix. The fixes are bad. The first fix is add return statement. And that makes the error go away, but that doesn't calculate a cube. The second fix is just change your mind and say the function doesn't return anything after all, and that's just bad news because it is going to return stuff. All right. If you look at the pseudocode back on the slide again, The pseudocode says once we are inside the method, we need to create or declare an integer called result. Now we are just blindly following the pseudocode. Somebody gave it to us, we're following it. And we need to translate that from the pseudocode, so that's going to be result semicolon. That's right off the pseudocode, right off the flowchart. Next in the flowchart is compute num times num times num, store it back into result. That's easy enough for us to do, so that looks like this. Result equals num times num times num. And I blew it already, didn't I? This should say num. My fault. If I'm following the pseudocode, it should say num. Little bit of a conflict. So the pseudocode says num and the method signature says number. So error on my part. I've done the computation. Eclipse is still not happy. I'm not returning anything. If I look at the pseudocode again, I need a return statement or some kind of return logic. That is one line of code. Result equals, I'm sorry, return num. And the error goes away. Eclipse is now happy. Life is good. We've implemented that method. The biggest mistake that everybody makes at this point is they walk away from it and they think they're done, but they are not done because they have not executed the method. It's sitting there, but it's never going to run. Remember, the only code that runs is what's in the main. When you click that run button, it jumps into the main. In this case, it jumps to line 7 and takes off from there. When it gets to line 9, it's done. You have to invoke that method from the main or from some other method that you invoked from the main. If you don't, notice there's no warning about that. It doesn't say, hey, Bill, you never called this method. It's never going to run. It doesn't tell me that. And the reason for that is because it's public and it's assuming somebody else might call it. Now, if I make this private, I get a warning saying, hey, this method is invisible outside of the class. No one else can see it, and you didn't use it, which means nobody is using it. And I just make this public. For our purposes right now, it doesn't matter. Let's invoke it. We don't need this nonsense anymore. We can blow away what's in the main and just retype it from scratch. So inside the main, we are going to do int, I don't know, data, and say data equals cube 42. And that is our what we call a call or an invoke. So we are calling the method or we are invoking the method. Those are two terms that people use. I usually say call, but sometimes I say invoke. That's going to transfer control into the method. That's going to put you in line 12. It executes the method, then it comes back and returns control to you again in the main. And we'll do that with the debugger in just a second. We're not done really though because we don't know if it works. We called it, but then we just gave up and walked away because there was a good show on TV or something. And you can see that there's a warning which is kind of helpful here. It says the value of the data is not used. It is kind of used. I mean, we put something in it with the equal sign. So data has something in it, but then we never take it back out again. It's like filling up a bucket with water and then just leaving the bucket there and not using it for anything. We need something that accesses what we worked so hard to get, and usually that's just a print statement. The line 7, there's no warning anymore. The warning is gone. So we declared the variable in line 7. We assigned a value to the variable in line 9. We printed the variable in line 11, and that completes the circuit. Eclipse has nothing to complain about at this point. And I messed up my method, I can see. The warning here says I didn't use result, and that's right. I should be returning result. Some of you are probably screaming at your monitors at this point. And there we go. Now we're good. This should run and should print out 42 cubed, which as we all know is 74088. And that's good. We implemented the flowchart and we followed the method signature. We did everything we need to do. From a systems engineer or from a software engineering perspective, it's not that great. For our purposes at this level, it's fine. It's perfectly fine. We'll talk more about why this isn't the best way to do it later. I'm trying to get you to come back. But for now, this is great, and this is the way you will do your work. You'll have a main still. We always need that main until otherwise directed. But instead of doing everything inside the main, we're going to start writing methods. Take a close look at what the main does. All the main does is demonstrate the method. I'll repeat that because it's important. All the main does is demonstrate the method. If I took the main out, remember, the purpose of this method is for somebody else to be productive. It could be you as well. Chances are it's going to go into a repo somewhere, and other people are going to use it. From their perspective, they will already have a main. So they don't want your main. It's just it's in the way. It's actually a problem. It shouldn't be there. Therefore, when we get better at this, we'll look at techniques for removing the main, which involves putting this method into a separate class. But we're not there yet, so this is fine. Some people, if they find themselves in this situation, will put the main at the bottom. I put my method at the top. Now notice everything is still in the class. All our code has to be in a class. But the main's now at the bottom. This doesn't make any difference at all. It still runs the same way, produces the same result, same warnings and errors. It's just not what I want to see. Because generally we think about code from the top down, and generally we want to see the most general code first in order to decide where we need to go when we're reading it. We don't read it like a book, chapter by chapter. We skip around. And we need to start with the main, which is the most general part of any program. Therefore, we want the main at the top. Just it's less scanning for your eyeballs. Again, doesn't matter, but it's just more commoner to put the main at the top. You're not quite done yet, though, because you still need to do your paperwork. And we have talked incessantly about what goes at the top. You know that. I'm not going to put that here because you don't need to watch me type. But now we have a new documentation requirement. Get ready. Right above the method. Okay, and outside of the main, outside of the method, but right above it, we're going to create a new kind of comment by doing 3 slashes, slash, 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 3 forward slashes, press enter, whoops, my fault, wrong language, slash and 2 stars, slash and 2 stars, press enter, and Eclipse builds what's called a Java doc comment. And this is a standard way of documenting classes and methods that we will use from now on. If you write a method, you need to Java doc it. And what you're going to put here is a one-sentence description of what the method does. The audience for this is other developers and you, not end users. If you can't describe it in one sentence, then it's too big. It needs to be broken up into multiple methods. Eclipse also wrote a couple of other annotated comments for you, which you will complete and that takes a little bit of thought on your part. You get used to it very quickly. Remember, you're describing what to do in order to use that function correctly. The first sentence tells everybody in the world what the function does, and see, now I'm calling it a function again. The first line says that this is what the method does. Not how it does it, not why it does it, but what it does. The next line defines what the parameter is that is required by that method. What do you have to send to it to make it work? And there may be multiple parameters. In this case, there's only one, num. The third line is what the method is going to send back, conceptually. Okay, nothing complicated. Watch what happens now. Make sure you click save. You probably don't have to, but just make sure you do. Watch me hover now over cube. So look at line 10. I hope you're sitting down for this. The Java doc comment that you wrote is now part of the documentation for this program. So all the neat things I put into that Java doc show up when I hover over any reference to that method. You might be thinking, so what, big deal? It's on the same page. It's right below there. I'd have to be a total moron not to know how to use it. That's true, but that's rarely going to be the case because that method will probably be in a different class, in a different file, maybe in a different project, who knows? And you'll be really appreciative over the ability to hover over that and see how it's supposed to be used. So far, so good. We've documented the method using Java docs. That is our new addition to our documentation requirements. You must do that. If you don't, you will lose points and or have it rejected back to you for revision. And we've written a method. What if I use the method incorrectly? Let's just try to break this, and it should be very easy. How about if I just call cube with no parameters? No arguments, rather. And I get Eclipse tells me, hey, you can't do that. That's really good. Eclipse is looking at my program over my shoulder. Hey, Bill, do this. Hey, Bill, you can't do that. And Eclipse looked at the signature of the method. Eclipse understood that it requires an argument here because there is a parameter in the method signature. And it says that I cannot proceed in this fashion because I need to provide that argument. The fixes aren't very good. In fact, they're awful. The first fix is add an argument. Okay, well, how does Eclipse know what value we want to cube? It doesn't. If you take that fix, it just makes a guess. And since there was one variable in our program, it decided that might be a good thing to pass to the method. It also says, hey, if you don't like that, I can put a 0 in there. So that's a total guess on the part of Eclipse, and you should never do that. The second fix is, well, line 14 is fine, but the method's wrong. So let's just rewrite the method to match line 14 and take out the parameter. Now, if you do that, you can imagine then we have a cascading number of problems because in the method body, it doesn't know what num is anymore because I took out the parameter. That's a bad idea. And the third fix is just make a whole new method called cube to match line 14. Make a method that doesn't accept any parameters. That way I don't need any arguments in line 14. And if I do that, the error goes away and I get a whole new method with no code in it. Again, all Eclipse can do is make the errors go away. Syntactically, it cannot fix logic problems. Again, bad idea. Let's say I do put a number in there, 100. The error goes away, but now I have a problem. Big problem still. Hopefully you can see the problem. You should be able to look at that code and tell me the problem. This function, here I go. This method returns an int, but I am not doing anything with it. I am ignoring the return value. Syntactically, that's fine. You're not going to get a squiggle for that. But logically, it's probably ridiculous since the sole purpose of that method is to cube the number. And the method calculates the cube, in this case of 100, sends it back to you, and then you just ignore it. It goes in the bit bucket in the garbage can. Logic problem, not syntax problem. We need to catch that, so we can say, let's how we're going to receive this. Int result equals cube. There we go. That works. And then we could print out result, of course. When we run it, we get the cube of 100, and I couldn't even imagine what that is. Another way to do that would be to simply invoke the method inside of the print statement. I don't need the variable anymore. Cube 100. This works too. Whoops. The only difference is we're not capturing the result of that method call. We're just printing it out and then continuing on. Three ways then we can deal with this when a function returns something. Or two ways. We can store it in a variable and then mess with the variable, or we can just pass it to another method. So the return value from cube here is passed as a argument to println. One function deals with the results of another function. And we do that all the time. There's nothing untoward about that whatsoever. Let's try to break it again. Let's say result equals cube. And I'm a little confused. I'm putting the number in quotes. Now I have a problem because the argument that I am sending to the method is not a compatible data type with the parameter in the signature of the method. I'm sending a string, but cube wants an int, and those two things are not directly compatible. It will not do a type conversion from string to int, and you get an error. The method cube int in the type methods, which is the class, is not applicable for the argument string. It's a good error message. It's just got a lot of terminology in it, and you have to wade through it. The fixes are terrible. The fixes are, okay, rewrite the method so it accepts a string, or create a new method with the same name that accepts a string. They both work. They both make the error message go away. They are neither one of which is what you'd ever want to do, probably. That's not going to work. I've introduced a little bit of a curiosity in this, maybe you've noticed. Look at line 28. I'm declaring a variable called result. And look at line 14. I'm declaring a variable called result. Well, we've learned from hard experience you can't declare a variable twice. That's impossible or incorrect. For example, if I came back up to the top of the main and just declared data again, then I'd get an error. Duplicate local variable. You can't declare a variable twice. But it seems like I am declaring it twice, does it not? I'm declaring it in line 14 as an int. I'm declaring it in line 28. Same name, but the difference is the scope of these. They are in different blocks. There's our old friend the block again. This one in line 14 is in the block that is the main method. Look at line 6 and line 21. That's the block. In line 28, that declaration is in the block defining the cube method that starts at line 27 and stops at line 31. Since they're in different blocks, they can have the same name and they are completely different variables. They do not overlap or interfere. It's not a problem at all. And actually, we do it this way a lot because it makes much more sense than trying to create a new variable name simply to be different from some other variable name. I want it to be a result. I mean, that's a good descriptive name of what that is going to contain. And the same thing down here. It's a good descriptive name of what that variable will have in it. But if I wanted them to be different, I could put an X on the end, and then that just gets ugly. I spend my time trying to create unique variable names when I don't have to do that. So the TLDR is that variables exist in a scope that is defined by the curly braces in which it's declared. And there's more to it than that. That will cover us for now. Variables exist. Variables are recognized inside of the block where they are declared. Some of you may have accidentally done this already. Notice that I am outside the main. Here, watch this. This will blow your mind. String test. We've been telling each other for quite a few weeks that everything has to go inside of a method, right? All the code has to go inside the main, or now today we learned all the code has to go inside the main or any other method. Well, it is possible to declare variables outside of all the methods. Those are class level variables. We are not doing that here. We'll do that in Java 2. Everything still gets declared inside of a main or a method. The main method is special because that is what runs when you click the run button. You have to have one of those in order to click run. If I change the name of the main, and I can do that, it's just going to cause me all kinds of grief. And I click run, it says something rather cryptic. Main method not found in class methods.method. That's helpful, but a Java FX application class must extend. That's pretty scary right there. So if you read the first part of it, hopefully it would trigger a memory that you don't have a main. And if you read on, you might just get all jumbled up. But that was a typo, and I will remove it. Everything's good to go now. Let's go back to the slides. The slide that we stopped at was write a signature for a method called foo that receives a double and returns an int. Okay, I gave it to you here on the slide. Public static we're not going to change. We'll always go with public static until told otherwise, which won't be until next semester. Return type is int. According to our instructions, it should return an int. It's called foo, F-O-O, and it accepts one parameter that is of type double. Notice what's not in the instructions. There's something missing from those instructions, and it should be missing. It's not supposed to be there. And that is the name of the variable. When you write the signature, you've got to compose a name for that variable, but that name really has no bearing on anything except the body of the method. So that name belongs to you. You can call it whatever you want. You're the one that's going to be manipulating it anyway. So don't get caught up in where does that name come from, who gives it to you. You make it up. You decide what it is. Make it descriptive and helpful, but it's up to you what goes in that name. If I take that signature right off the slide, go back to Eclipse, and now I'm going to add another method to this class, this mishmash we have going here. So I'm going all the way to the bottom and right inside that closing brace, right inside the last brace on the page. If I click on that brace and scroll up, you can, if you look closely, you can see that the brace in line 4 is it's got a square around it. It's kind of highlighted. So it's showing you where the braces match up. You can click on one brace and scroll, and it will show you the matching brace. And that's pretty neat. I'm inside the class. I'm outside of all the other methods. I can paste in that line of code right off the slide and provide the braces. There you go. Still have a problem though, because the method has promised to return or send back an integer, but I'm not doing that in the code. I can put a return statement in here, return 42. This method does nothing. It's a sad little method, but it illustrates the mechanics. And then finally, I would Java dock it. And this one's embarrassing. I wouldn't even write this method. This method does nothing except demonstrate a method. And the parameter that it expects to receive is bar. Bar is a made-up name. I'm not going to tell you where it came from. I'm not going to tell you where foo came from either. Made up name that does nothing. This is very silly. Return 42 all the time. We would never do this. We're just showing you how methods go together. Our next exercise says, modify a programming exercise from the book to use a method besides the main. Retain the main, but move the logic to a new method. Finally, call the new method from the main. We're just practicing modularizing our code. We have something that works, but it's all jammed inside the main, and we want to break it out. And I am going to go back, instead of using something from the book, and I'm going to use something that we've written before. And I'm just scanning through the list, and I see Project Euler Problem 001. That takes me back. That was a fun time for us so long ago. If I open that module, there's the solution for Project Euler Problem 001. And this should look a little bit ugly to you right now, because you know that we modularize our code. In this case, we did not do that. It should give you a little bit of a headache, a little bit of blood pressure increase. This just doesn't look right anymore. If I gave you this and you wanted to incorporate it in your big monster project that you were working on, you'd have to chop out all of my code and put it into a method and then delete my main, and that would make you mad at me. And you wouldn't sit with me at Chipotle anymore. we need to modularize this. Now I have two choices. I can copy the project and start from scratch, but Eclipse makes that a bit of a headache because you can't have two projects with the same name in a workspace. So that won't fly. What I'll do then is I'll just make a new project. New project. And I will call this PE problem 001 modularized. How about that? PE problem 001 modularized. New project, there he is. New class. The class will be PE001. The package will be, how about just PE? We may write other solutions in this class as well. Let's just keep it general. Project Euler 001 is our class name. PE is our package. Do we need a main? Yes, we still need the main. Click Finish. There it is. Clean out the stub. And don't forget that we would document this, so I would put stuff up here. You just don't need to watch me type it. Now, I want to take everything that we wrote a couple weeks ago, all of it, chop it right out of the main. I want everything but the main. So I highlight all the code inside the main, copy it, go back to my new class, and I don't want to paste it inside the main. That defeats the purpose of attempting to modularize this. Let's make a new method and paste it in there. Now what should that method look like? Well, Project Euler problem 001 computes an integer. Therefore, this function should compute that integer and return it to whoever called it. And then we will call this Project Euler problem 001. That's a good name. It doesn't need any parameters. It's self-contained. It knows what the values are, the starting point, the ending point. We have a complete working version of this. It just was not inside of a method. It was built into the main, which was inconvenient. So let's just paste in all that code that we copied. And I have a little bit of a formatting problem. I noticed there's two braces on the same line. I'll just try to clean that up. Let's see. That goes with that. Well, I have too many braces. So I guess when I copied this, I copied too many braces. I did. I copied one extra brace there. I just need to get rid of one of these. There we go. All right. The problem we've already seen twice. This method is committed to return an integer, but it ain't returning nothing. What do I return? This method computed something called sum. And in the previous version of this, we just printed it out. In this case, though, we're going to return it. Return sum. We are going to remove the print statement. The method is not going to print, and nor should it print. The method's job is to compute Project Euler problem 001 and send it back. The method's job is not to print. Okay, let's add our Java doc. Compute Project Euler problem 001, return the solution. How about that? That's all it needs. Not how it does it, not why it does it, not the algorithm. It just describes the method and how to use it. How to use it is pretty easy. All you do is call it. It sends you back the answer. This is how we work. This is how we work. We write methods. So think in terms of methods. Finally, we need to call it. Remember, it's sitting here in space, fat, dumb, and happy, but it's not being called. It's never going to run. Inside the main, then, we will say system, whoops, sort out, dot println. Let's put some friendly stuff in here. Project, Euler, problem, 001 equals plus. We'll just grab the method name and some parens. We are off to the races. We have modularized that exercise. When it runs, we get the exact same answer. 233,168. I should have that memorized by now as many times as I've written this. But now it's better, and we're working towards becoming better developers because we put it into a method. That's what you will do. Eventually, those methods will be put into separate classes. Those classes will go in separate packages. Those packages will go into various projects, and then you will officially be a Java developer. Thanks for watching. Bye-bye.